Hello, this is module 6. It's about data data link layer. So data link layer, it's to the OSI. Uh, so the previously we looked at the physical layer, which was layer 1. Now this is layer 2, which is data link layer under OSI model. So the areas or the topics to cover: purpose of data link layer, then topologies, data link. So what's the purpose of the data link layer? The data link layer is responsible connections between end device SCAD. It allows upper layer protocol. The upper layer access the physical layer media. So let's layer 3 packets. Layer 3 packets, that is IPv4 IPv6 into layer 2 frames. It also performs what you call error detection and rejects invalid frame or collapsed frame. So mainly at the data link layer, expect in the encapsulation process, once the data link layer receives a packet as a PDU, protocol data unit, to add what we call the data link layer header and then a trail. So in the header there is always source MAC address and destination MAC address, as we're going to look at the data link frame. So IEEE LAN-MAN standards LAN, its network, local area network, and MAN, its metropolitan area network. Standards are specific to the type of network, be the Ethernet. Now when it comes to Ethernet, this with Ethernet, that is wired, wireless LAN, then we have wireless PAN, personal area network, and others. So data link layer consists of 2 sublayers. Sublayers, we have logical link control, and then we have media access control. So the logical link control sublayer communicates between the networking software at the upper layer and then the device hardware at the lower layer. So it's between the network software at the upper layers. In other words, the applications that is used, and then the device hardware at the lower layer, that is at the data link layer and the physical layer. So we have what you call the MAC sublayer, which is media access control, is responsible for data encapsulation and media access. The encapsulation, so it's the MAC sublayer that adds or that encapsulates package into a frame, and still it's responsible for the media access control. So when you look at our layers here, we have network layer, which is the upper layer now, one of the upper layer. Then our data link layer, it's this, but subdivided or with the sub layers: logical link, control, and then the max, the one that is in to communicate with the upper layers, uh, and that is with the applications used. And then when it comes to sublayer, now it's the one in charge to with the encapsulation. Now it can actually determine, is it wired, is it wireless, and then PAN. Then with various Ethernet standards for fast Ethernet, gigabit Ethernet, and so on. Various wireless standards for different types of wireless. For different types of wireless. Is it Bluetooth? Is it Zigbee? Is it Wi-Fi? All that. And then when it comes to various wireless, this for actually this wireless. Then we have Bluetooth this side for personal area network. Packets exchanged between nodes may experience numerous data link layer. That's the packets that are exchanged between nodes, between that are network devices. They may experience numerous data link layer. That every time a device, a node receives, then automatically that packet it has to go through link layer, the different link layer, and still media transition. So from point to point, there is always a network media. It's not a must that they have to be the same, so they can actually traverse through numerous data link layers and then the media transition. So at each hop along the path, at each hop along the path, a hop, those are the routers. You need to note that. The data link layer, that is if it's maybe from this, for example, still on the data link layer, then the hop. Now, um, every time because like right now here, this is our PC, and then this is our PC. So this, every time the um, package is received, then it has to go through, it has to be encapsulated up to actually the network layer, up to network layer. So it will have actually gone through the data link layer, and but still the reason why it has to go through all those processes is to be checked, get to know where they are from and what are the sources and what are the destinations and the destinations. So at each hop along the path, a router performs four basic layer 2 functions. One, it accepts a frame from the network media from the cabling, the connection. And then once it accepts, it de-encapsulates that frame to expose the encapsulated package. What is encapsulated? What is encapsulated in the frame? And then after exposing the encapsulated package, then that packet it has to be re-encapsulated. Uh, uh, it has to be re-encapsulated into a new frame, and then that new frame it is forwarded on the medium of the next network segment. So those are the um, uh, uh, four basic functions. Data link layer standards. Data link layer protocols are defined by engineering organizations where we have Institute of Electrical and Electronic Engineering, Institute of Electrical and Electronic Engineering. We have International Telecommunications Union, and then International Organization for Standards, and then American National Standard Institute. So all these, they are engineering organizations that are there to govern the data link layer, or whatever that takes place to data link layer. So topologies. So the topology of a network is arrangement and relationship. Arrangements and relationship of a network devices and the interconnections between them. Interconnection between them. So there are two types of topologies used when describing a network. We have physical topology and then logical. So for physical, it shows physical connections and how devices are connected. Physical connections and how devices are interconnected. Logical, it identifies even the virtual connection. Virtual, something that is virtual, you cannot see it with the naked eyes until you have to run some configurations. So the virtual connections between devices using device interface, you can imagine. Now you're able to see the interface, but what is set on the interface? The IP addressing schemes. Mm. So for which since so this is like a quick sketch here, and then when it comes to this, it's a detailed sketch. A detailed sketch. So there are three common physical one topologies where we have point to point. The simplest and most common one topology consists of permanent link between two endpoints. So point to point, we expect something like this. We have A, then B, period. That is it. That is our point to point. We have hub and spoke, similar to star topology, where central site interconnects branch site through point to point. So we can have something like a headquarter here, and then it is connected to the branch. This is the headquarter. This branch, we can have branch 2. We can have branch uh, 3. So it is in form of all this star topology, because a star topology, this is it. So as you can see, it is almost the same here, but there is a branch connecting to. So most of the time, I always refer it to as ISP, and then these as clients. Client 2 is client 1, client 3. So on this, you can have as many actions as possible. But when it comes to this, the headquarter expects one branch. As you can see, it's this, and then it's in form of point-to-point link. Then we have mesh, provides high availability, but requires very end system to be requires every end system to be connected to every other end. Um, so for mesh, let's assume that we have a router here, this. So each end, it has to be connected to every uh, other end system. So here, and then after that, this, it has to be connected to this, and then this. So this has to here, and then where, and then connect. So this, it has to connect here, and then connect on this, something like that, as you can see. So in case, let's say, one is down, it will not stop these others from communicating to each other. So this is a point to point. We have already talked about this. through. Then we have what you call the LAN topologies, local area network topology. So this is the star. We have a star here where we expect an intermediary between, and then we have extended. Now it's this connecting more than one. um, this here and then this. uh, so that is extended, or you can call it tree. Then we have what you call the legacy, the early Ethernet and legacy token ring topologies, where we have bus and then ring. All end system are chained together with the bus. Where is the bus? They are chained together and terminated on each end. Chained together, as you can see. This we have a ring. With the ring, each end system is connected to its respective neighbor to form a, you can see that it has to change together like that. But those are legacy. So half and then duplex communication, it's only with half, it only allows one device to send and receive at a time on a shared media. On a shared media, it's common actually on wireless because it's a shared media. And then even the legacy legacy topologies, where they used to use hubs, used in wireless and then legacy bus. Yeah. And then full duplex communication allows both devices, all the devices on that network, to send and receive on a shared media simultaneously. And it's common on our Ethernet switches that operates in full duplex mode. So we have what you call connection-based access. All nodes operating in half duplex are competing for use of media. For example, carrier sense multiple access with collision detection as used in legacy bus topology Ethernet. Carrier sense multiple access with collision avoidance as used on wireless. So with this carrier sense multiple access with collision detection, it has the mechanism used on legacy and then the bus topology. But when it comes to collision avoidance, carrier sense multiple access collision avoidance, it is used in wireless LAN. So control access, deterministic access, where each node has its own time on the media. For this, every time if they are to use that method, because it does not mean that that method cannot be used, but every time uh, nodes to use that mechanism, then automatically they have to have time stated. And I always use the example of traffic lights. Traffic lights. So those traffic lights, they keep allowing and stopping vehicles from each direction, but they are given time. When the time elapses, then either allowed or stopped. So used on legacy is the controlled access used on legacy networks such as token ring and then ARCnet. So with carrier sense multiple access collision detection are used in legacy Ethernet LANs. Those are the bus. Operates in half duplex mode where only one device sends and receives at the time. Uses collision detection process to govern when device can send and what happens if multiple devices at the same time, what will happen. So the collision detection process here, devices transmitting simultaneously will result into signal collision. Signal collisions. So once the devices send simultaneously in carrier sense multiple access collision detection, we expect signal collision on the shared media. So device detect the collision, and then devices wait randomly period of time and then retransmits. That once the collision takes place, then the device they had would detect collision, and then device they will have to wait randomly period of time, and then after that random period of time, they can resend again. That is if the media is idle or free. So with carrier sense multiple access collision avoidance is used by wireless LAN, operates in a still in half duplex mode where only one device can send and receive at the time uses collision avoidance process. The other one was detection. It detects collision and then waits randomly period of time. Now this one here, it's collision avoidance process to govern when a device can send and what happens if multiple devices send at the same time. So the process of collision avoidance when transmitting a device also includes time duration needed for the transmission. So when in this mechanism, when a device is transmitting, then the time it has to be attached, like those traffic lights. Time you're stopped maybe for 1 minute and it keeps counting. Then other devices on the shared medium receives the time. So you can be stopped and then told the time to wait. Then the other one, they are loud, but still it's the same uh, thing, it's the same scenario. You are allowed for a minute, you're stopped for a minute. After a minute, then the other one will be stopped, and then this one will be out. Data link frame, we're going to look at the data link frame. Data is encapsulated by data link layer with header and then the trail. So with data link layer, it has to add a header and then a trailer to form what you call a frame. So a data link frame has three parts. We have a header, data, and then a trailer. So the field of the header and the trailer vary. The fields within the header and then the trailer, they do vary according to data link layer protocol. What does that mean, the data link layer protocol? That is if it's, is it, okay, within the, within the data link layer protocol, we're going to look at the protocol used at the data link and the data. Yeah. So the amount of control information carried within the frame still varies according to the access control information and then the logical topology. So there is a frame and then different fields. So we have frame start, addressing, type, and control within the header. Package data, we expect data, and then the trailer, uh, error detection, and then frame stop. And their description, they are here. Frame start and stop identify the beginning and end. Addressing indicates source and destination nodes. Those are from MAC addresses. Then the type identify the encapsulated layer 3 protocol. Is it version 4 or version 6? Control identifies the flow control service. How the governance, the governance. Then data contains the frame payload, the exact data that is being exchanged. Error detection is used for transmission. It is used for determining uh, transmissions error. Layer 2 Layer 2 addressing, also referred to as physical address contained in the frame header, is used only for local delivery of a frame on a link. So the layer 2, they are used only for local delivery. What do we mean the local delivery? This is so it can only be used in those on the local, the same network here, the same network. Now, when you look at this, yes, this computer is trying to reach the final destination, but the MAC address for this computer, it will actually be used on this network. And once the router 1 receives, it's going to replace the MAC addresses stated between this point to this with the MAC address here between this. So by the time this router receives a package, then the MAC addresses from this network will be replaced. Even when router 2 receives, it will replace this MAC address with this, but the IP addresses remains the same. That's the reason why this color remains the same, but with layer 2 keeps on changing here, then this to this, meaning that there is a replacement there. The logical topology and physical media, it determines the link layer protocol. Logical topology, of course, the logical topology, it depends on the connection, and then the physical media determines the data link protocol. So here we have Ethernet, we have wireless, we have point-to-point, high-level data link control, and then frame reload. So each protocol performs media access control for specified logical topologies. So topologies. So that marks the end of this session.